Welcome back to the channel, data enthusiasts. Today, we're diving deep into two fundamental statistical tests crucial for effective feature analysis, the T-Test and ANOVA. Understanding these tools empowers you to uncover significant differences between groups in your data, a vital step in feature selection and building robust models. In the world of data science, we often need to determine if observed differences between groups are truly meaningful or simply due to random chance. This is precisely where statistical tests come into play. They provide a structured framework to make data-driven decisions, preventing us from making assumptions based solely on intuition. Let's begin with the T-test. At its core, a T-test is designed to compare the means of exactly two groups. Its primary purpose is to determine if the means of these two groups are statistically different from each other. Think of it as a way to assess if the treatment you applied truly had an effect compared to a control. One common variant is the independent samples T-test. This is used when you have two separate, unrelated groups, such as comparing the average test scores of students who received a new teaching method against those who received the traditional method. We want to know if the difference in their average scores is statistically significant. A practical application of the independent T-test is in A/B testing. Imagine you're rolling out a new button design on your website. You can randomly split your users into two groups. One sees the old design, and the other sees the new design. A T-test helps determine if the new design significantly changed key metrics like click-through rates. Another crucial type is the paired samples T-test. This test is used when you have two measurements from the same group or matched pairs. For instance, if you're evaluating a weight loss program, you'd measure each participant's weight and the program. The paired T-test assesses if there's a significant change within the same individuals. Before running a T-test, it's important to consider its assumptions. The data should be approximately normally distributed, observations within each group should be independent, and for independent samples, the variances of the two groups should be roughly equal. Violating these can affect the reliability of your results. Now let's expand our scope to ANOVA, or analysis of variance. While T-tests handle two groups, ANOVA is the go-to statistical test when you need to compare the means of independent groups. It assesses if there's a significant difference between the means of any of these groups. The most straightforward form is the one-way ANOVA. This is used when you have one categorical independent variable with three or more levels, and one continuous dependent variable. For example, comparing the average sales performance of three different advertising campaigns. Consider a practical scenario. A company is testing three new product formulations. They distribute samples to different customer groups, each receiving one formulation. ANOVA helps determine if there's a statistically significant difference in customer satisfaction scores across the three formulations, indicating which one performs best. Similar to T-tests, ANOVA also has assumptions. These include the dependent variable being approximately normally distributed within each group, observations being independent, and the variances of the dependent variable being equal across all groups. Interpreting the results of both T-tests and ANOVA often hinges on the p-value. A small p-value, typically less than 0.05, indicates strong evidence against the null hypothesis, suggesting that the observed differences between group means are statistically significant and unlikely due to random chance. If your ANOVA is significant, you would typically follow up with post-hoc tests to pinpoint exactly which groups differ. These statistical tests are indispensable for feature selection. By identifying features that show statistically significant differences across various target groups or conditions, you can prioritize and select the most impactful variables for your predictive models. This leads to more efficient and accurate model building, avoiding noise and focusing on true signals. In conclusion, T-tests and ANOVA are powerful tools in your data analysis arsenal. T-tests efficiently compare two groups, while ANOVA extends this capability to three or more. Mastering their application allows you to make informed decisions about group differences, validate experimental results, and ultimately, select features that truly matter, driving better insights and more effective data solutions.